We are now officially on Precalculus 5th edition Mathematics for Calculus, section 1.2. So let's go ahead and get into it. I will solve each and every problem in this section, and you can download the PDF in the notes or the description of this video. And feel free to get on the email list for updates. Alright, so let's get going. So we want to rewrite each of these exponents as exponentials or vice versa. Starting off with 1. 1 over the square root of 5 is the same thing as 5 raised to the 1/2, negative 1/2. Because it's a negative exponent on the bottom and raised to the 1/2 is a radical. Same thing as 7 raised to the 2/3, because that's a cubic root. Cubic root of 4 squared. You could put a 16 there. 1 over the cube root of 11 squared, or 121. Two divided by 3 is 1.5. Or, no, that's not right. 3/4. All right, so we're ready for the next section. So evaluate each expression. This is equal to negative 9. You evaluate the exponent first, the negatives on the outside of the 3. This is equal to 9, and this is equal to 1. Anything raised to 0 is 1. So this is 1 over 25, so it's the same thing as 5 squared over 5 cubed, which is 125, which reduces down to 1/5. You can subtract this. This becomes 3. This is equal to 1,000. 10 cubes 1,000. 10 times 10 is 100. Times 10 again is 1,000. This is the same thing as 3 raised to the 1. And then this can be taken up here, so it's plus 2. So it's 3 cubed, which is 27. So you can write this as 2 raised to the 8th over 4 cubed, which is equal to, see, 2 raised to the 5th, 32, to the 6th, 64, 7ths, 128, and 256. Is equal to 4. This is equal to 1 over 81, because the 3 goes on the bottom, 3 squared. It's 9 times 9, 64. 27 over 8. This is going to be the same thing as 2 squared over 3 squared, so it's going to be equal to 4 over 9. So this reduces this down to 4. These cancel out, so we get 1/4. So this becomes 1 over 16 times, you can reverse these, so we end up with 4 over 25. I have no idea what that is. Actually, I do. This should actually be 1 over 8. This reduces down to 16. This becomes 4. Okay, so this becomes 1. All right, so it's 1 over 100. All right, continuing on, this is equal to 4. This is equal to 2. 2 raised to the 4th is equal to 2. Or 16 is the same thing as 1 raised to the 1/4, so it's 1 over 2. Because if you raise these to the 4th, 1 raised to the 4th is 1. 2 raised to the 4th is 16. This is 8. I think that's negative 8. Negative 8. Negative 2. 2 over 3, because each of these cubed is cube root of each of those 2, and then 3. This is equal to negative 1 over 4. A little trick here, we can rewrite this as the cube root, or excuse me, the fifth root, and then negative 3, 96, same thing as negative 1 over 32. And the cube, or the fifth root of 32 is equal to 5. And since we've got an odd cubic or a root, we can pull out the negative, so we get negative 1 over 2. Alrighty. So continuing on here, what we can do is combine these, so you can break down 28 into 4 times 7. And each of these can be broken down into square root of 49 and the square root of 4, which is equal to 7 times 2, which is equal to 14. Or no, that's not right. Same thing, 7 times 2 root 7. So it becomes, yeah, I was right. Sorry. And then square root of 49, so that's equal to 14. Okay. So here we can break this down to 16 times square root of 3. Pull out the 16, we get 4 root 3. And this 3 and this 3 on the bottom cancel out, and we end up with 4. So we can break this down to this can be broken down into 1296 raised to the 4th, which can be broken down into 36 squared raised to the 4th. This is equal to 4th root of 6 to the 4th, which just becomes equal to 6. Here, what we can do is inverse these, so we end up with just 3 over 2. Take the 5th root first, and then we have negative 2 raised to the square, which is equal to 2. All right. Which is equal to 4. Excuse me. Here we're going to end up with negative 4, I believe. Yeah. Same principle, except there's no parentheses. 1/10. That's, yeah, 1/10. So basically what would happen here is 2 raised to the 10 is equal to that. Binary. All right, so here what we do next is, so 2/3 take the cubic root of each, so we end up with negative 3 over 2, and then square both. And since this is a parentheses, we end up with 9 over 4. And finally here, take the square root first, so we have we'll put the 8 on top and the 5 on the bottom because we'll use the negative sign here. And then we have cubed, so we end up with not cubed, or squared, so we end up with shoot, 5 cubed over 8. Oh, that's not right. Sorry. And then square them. 64 over 25. Okay, that's right. So go ahead and evaluate each expression. Just plug and chug. So for 19, plug in for x, so 3 squared plus 4 squared. Pythagorean theorem, it looks like square root of 25. We get 5. 20, we get fourth root. So we get 27 plus 14 times 4, 56. And then this ends up being minus 2. Fourth root of 81 gives us 3. 3 to the fourth, 81. All right, 21. So we're going to end up with 1 plus 4 cube root 3 squared, so that's 9, is equal to 14. And finally for 22, 3 times 4 raised to the negative 2. So we get 12 raised to negative 2, which is equal to 1 over 44. 144. All right, sweet. Moving on. Let's simplify the expressions here. So we've got square root of 32. So do that. We can break this down to 16 times 2 plus 9 times 2. So we get 4 root 2 plus 3 root 2, which is equal to 7 root 2. We can combine these because they have the same radical form. Okay, and then here, this is 23. 24, we have square root of 75, which is 25 times 3. I'll move it up here, sorry. $16 times 3. Perfect. 75 times 3, it's 25. So that combines to be 9 root 3. Okay, so furthermore, we can break this down into I'm skipping 25, but we'll get it. All right, so this is equal to and we can just pull out the 4 root 3, and then we have minus the root 4. Root 4, 3. So this just becomes 3 fourth root of 3. Okay. And then finally, 25 going back, we have fifth root, so 32. So it looks like we're going to break this down into 32 times 3 plus fifth root, root 3. So we get 3 out of, or excuse me, not 3 other. That's going to be a 2 raised to the, 2 raised to the fifth. 2 raised to the fifth. So we get a 2 out of there. Plus fifth root of root 3. So we end up with 3 to the fifth root 3. That's it. Alrighty. Moving on. So when you have same base terms and there's positive or negative exponents, you just add those together and that's the final result. So here, eliminate any negative exponents. So if we do have a negative exponent, we got to write it 1 over to get a positive. So this is a raised to the 4th. This is going to be 12, y raised to the 7th. Here we're going to get 6, x raised to the 7th, y raised to the 5th. This is going to be 36, 216. 216 y raised to the 3rd. And when you have an exponent on the parentheses, it's the same thing as putting the exponent each component inside the parentheses. So we've got x raised to the 9th times that's 16 x raised to the 4th over x cubed. This cancels out one of these, so we end up with 16 x raised to the 10th. All right. This essentially goes up, and it becomes a raised to the 5th, so we end up with a raised to the 5th over b. Because this cancels that completely, and this goes to 1, and then it's just like a raised to the 5th on top, a raised to the 3rd on the bottom. And this should be a raised to the 2nd. Okay. All right, here we go. Let's see here. I'm going to have to figure out how to write these with the work showing the work. Okay. So b raised to the 4th. So 1/3. So it's going to be 1/3 of 12 is going to be 4. So we have 4 b raised to the 6th over b raised to the 8th on the bottom. So this just becomes 4 over 4. This becomes 4 over b squared. 2 is 1/2, so 1/2. So that becomes 1/2 of 16, so that becomes 8. You know, I pressed the, I don't know why the button's on the bamboo pad. Maybe, well, moving around the screen, but I hit it and it creates a mess. All right, so this is going to be equal to 8 t on the bottom there, so that cancels one of these t's out. So t raised to the 3rd, st. We don't have to worry about putting them in alphabetical order. T on the bottom. So t raised to the -1, so that's going to be the same thing as erasing one of those t's, which I just did. So that's s raised to the 9th. That's it for that one. All right, so over here, r cubed, s cubed. So same thing as having them on the bottom. So that's pretty much going to cancel out. So it's going to be 4 to the 4th, so that's going to be equal to 256. So essentially what we're going to end up with here is 64, because this cancels out down to 64 again. Shoot. 64 SR raised to the 7th. Okay. So for 37, 6 raised to the 4th. That's a large number. 216 times 4. It's going to be 864. I bet it is 864. 1296. $648. Y raised to the 8th. All right, so over here, same thing. So we get, and you multiply exponents, but then if there's an exponent there, you multiply them. So we're going to end up with 4x raised to the 6th times 3x raised to the 4th. $12x raised to the 3rd. Made a mistake here. So it should be actually equal to, this is 12 on the bottom, I goofed up. That's 12. So then x, this is 10th. X on the bottom, so we just get x squared on the bottom. All All right, look like I got some space down here. So what we'll do here is we end up with x raised to the 8th, y raised to the 12th times x raised to the 3rd, y raised to the 12th. So we end up with x cubed over y. Over here, so this becomes c cubed d times d to the 6th over c to the 9th. I think that's d raised to the 7th over c raised to the 6th. Let's check. Yeah, that's what I got. Okay. Alrighty. Alright, I'm just going to go with this for now. I know I didn't get the entire thing done, but I just want to see if people are even using this, and because it's incredibly time consuming, and if nobody's using it, I don't want to create it. It's not enough value, so we'll see what happens here. So anyway, take a look at that. Download the PDF with all this work that I have right here, and you can download this, watch the video, and so forth. So, all right, I appreciate you watching.